Assalamu alaikum students. Today is our 13th lab of OOP and Data Structures lab. The title of the lab is Implementation of Binary Search Trees Using Linked List. I will show you that how you will create a tree by creating nodes, and we will create nodes using the linked list concept. As we have already implement the code of queues and stakes using linked list. So in this lab we will also implement the binary search tree using the linked list concept, and hope that this you have already learned in your theory course, so you will have a good understanding and a better concept of binary search trees and its implementation. In this lab I will show you that how in C++ you will write a code for implementation of binary search trees. This is our previous labs. We have done 12 labs in OOP and Data Structures lab, and today is our 13th lab. So the objective of the lab is to familiarize students with binary search trees, operations, insertion and traversal implementation using linked list. In this lab we will create a tree by inserting node to it, and we will create the nodes by using the linked list concept, and we will also traverse the tree, that either we will write down the order of the nodes, that either how to write the order of the nodes in order, as we have three orders in the trees: in order, pre-order and post order. So the procedure that first for writing the C++ program, you have to create a node class for a binary search tree, as we have already created a node classes for the queue stakes. So in implementing the binary search tree, we will also create a node class. Then we will create a function to insert elements in a binary search tree. Then we will create functions for in order, pre-order and post order traversing in a binary search tree. So this we will do in our code. This was our overview of our code. Now coming that what is a binary search tree? A binary tree with such a property that items in the left subtree are smaller than the root and items in the right subtree are larger than the root is called a binary search tree. Mean if we have a root, so at the left side we should have a smaller than root, while at the right we have larger at the right. The building process of a binary search tree is actually a process of storing the data in a sorted form. Binary search tree is a kind of data structures in which we will store data in sorted form. The binary search tree and its variations play an important role in searching algorithms. You can the tree it will consist of the nodes, and if you want to search any node or any data among the nodes, so you can use the searching algorithms. As data in binary search tree is in an order, it may also be termed as ordered tree, as we have already discussed that we have three orders: the in order, the pre-order and the post order. So that's why it is also called an ordered tree. In a linked list, the printing of stored values is easy. It is due to the fact that we know where from a programmer needs to start and where the next element is. As in linked list, we have the nodes are connected with each other, but trees are different from linked list, as we have a root, so root will be connected to the two nodes, and then the two nodes will be connected to the more two nodes. So that's why that the insertion is a bit difficult in implementing trees. So in a linked list, the printing of stored values is easy when we stored any values in the linked list or delete the nodes. So it is easy. It is due to the fact that we know where from a programmer needs to start and where the next element is. Equally is true about printing of the elements in an array. We execute a for loop starting from the first element index 0 to the last element of the array. As we have done programs on array, we implement arrays. We write two loops in which one the user enters the values, while the other loop we implement for printing the user's elements as a output. So we implement the arrays using for loop. Suppose there are three nodes. If we coming towards the tree, if we say that we have three nodes with three numbers stored in it as shown below, as the figure shows three nodes and there are three numbers written in it. So in figure, root node has the 14 is a root node, so we called it a root node. The left subtree has only one node. Number 4, the left has only one node, as the root has only one left side. Similarly, the right subtree consists of a single node with the number 15. As at left and at right we have single nodes, single node at left and single node at right, and the 14 is our root. So if we apply the permutations combinations on these three nodes to print them, there may be the following 6 possibilities. Mean these are the positions of the nodes. As the 14 is the root, so it is just like the root is in the middle, while the left is 4 and the right is 15. In this, the root is at start, while then first left and then right, mean just like this. Mean first you have to write the left one, then the root, and then the right one, and then in the second you write the root, then the left, and then right, and then you write right one, left and root, then left, right and root, then root, right, left, then right, root and left. So there were 6 combinations in which you can write the order of the tree. In the first combination, the order of printing the nodes is 4, 14, 50. It means that the left subtree, root, right subtree, mean this is the left, in the middle the root is mentioned, and then the right subtree. In the second combination, the order is root, left, just root, left and right, as we have already discussed. In the third combination, the order of printing is right, root and then left, just right, root and then left. In the third combination, so in the third we have the right, there was a mistake in it, right, left and root, right, left and then root. Then in the fourth we have left, right and root, left, right and root. Then in the fifth we have root, right and left. In the fifth we have root, right and left, and then in the last sixth we have right, left, right, root, left. So right, root, left, these 6 possibilities are for the 3 nodes only. If we have a tree having a large number of nodes, then there may increase number of permutations for printing the nodes. By definition, a binary tree consists of 3 sets: root, left subtree and the right subtree. As we have only 3 nodes in this tree, we have only one root. Root is at the top, so there will be only one root in a tree, and then we have a left, but in the left and the right we have only one node. So the following figure is the node. This is the node, this is the left subtree, and this is the right subtree. In figure, root node is labeled as N, the left subtree is in a triangle labeled as L. The left subtree may consist of any number of nodes, mean it can consist number of nodes. As you have a tree, it will just like a shape of tree. Similarly, the right subtree is enclosed in a triangle having the label R. This triangle of right subtree may contain any number of nodes. So following are the 6 permutations which we have made for 3 nodes previously. To generalize this permutation, we use N, L and R as abbreviations for root, left subtree and right subtree respectively. So this is the left node, and then right node, left and right, right, left and node, and just like the combinations like we have discussed in this. These are the same like this. In these permutations, the left and right subtree are not single nodes. These may consist of several nodes. Thus, where we see L in the permutation, it means traversing the left subtree. Mean if we see L, so it means that it is the left subtree. Similarly, the R means the traversing the right subtree. In the previous tree of 3 nodes, these left and right subtrees are of single nodes, but it is not in every case that we have a single node. We have more than one nodes in a left and right subtree. However, they can consist of any number of nodes. The first of these 3 is a node, left and right, also called as pre-order. As I have told you that we have 3 types of orders: the pre-order, in order and the post order. So in pre-order we have first the root, then left and then right. In the in order we have left, the root and the right. In the post order we have left, right and then the root. So there we have 3 combinations: the pre-order, the in order and the post order for any binary search tree. Mean if we have root at the start, so it is a pre-order. If we have root in the middle, so it is a in order. And if we have root at an end, so this means that we have a post order. So we have 3 types of orders: the pre-order, in which we have the root at the start; the in order, in which the root is in the middle, the node is in the middle; while the third is the post order, in which the root is at the end. Now coming towards the implementation of the tree. For implementing it, as we will implement it through the linked list. So for implementing a linked list, we will create a class for node, as we have already have done this for the queue and the stake. So it is same as we have done for the stake and the queue. So if we are creating the node for a tree, so just you have to include the headers, the iostream and the using namespace SDT, and then you will write the name of the class. I have write the name of the class is node underscore t. So for this we will initialize the members, declare the members privately, and we will create the functions publicly. So as we have data, so the node will consist of a data, and it will have two pointers, the left pointer and the right pointer. As we are implementing the tree, so it will consist two pointers, the left and the right pointer, and the data will be as a integer, will be declared as an integer, while the two pointers we will create with the name of the class. Publicly, the first function is the constructor function. This is the default constructor for assigning the variables 0, as in this we have assigned a 0 to the data, while a null to the left, while right mean we have nothing in a tree, as if the left is null and the right is null, so there is no tree, and as the data is assigned a 0. Then we will have a function set data, in which we will assign data to the nodes, and then get data will give you the data of the nodes. Now for the two pointers, first you have to set the left, that for this you have to create a next pointer, and you will assign it a left pointer, and then we will return the left, the other pointer get left. So in the function set left we will assign it we will assign left a next pointer, and then in the get left it will return us left pointer. Just like for left, we will create a function for right and assign a next pointer to the right, and we will also for returning right we will create a pointer get right, and we will create these pointers with the name of the class. Now for this is the at the end we have, as we have create a function for the data, and then we write a function for the left pointer, and then we write a function for the right pointer, and then we assign a next pointer to the left and the right, and then we create two pointers, get left and get right. Code for leaf node. So the leaf node is bool is leaf, that either so we will check that if this left is equal to null and this right is equal to null, so return true, else it will be false. Mean we will check the left and the right if they are null, so this is the leaf. For inserting nodes you will first check either your left and right are null or not. If they have any values, so for checking either the tree for leaves, that bool is leaf, so you will check either the left or right is equal to null, so it will return you true, otherwise it will return a false for you. This is bool we will write for any functions if you want to check. So this is the code for leaf node. Now for implementing the tree, so I have create a cpp file of node underscore t, and the above code you have to write the above code in a cpp file and save as with the node underscore t, then you can include this file to the tree. So it will be easy for you, so you can call it for implementing trees. Mean if you will have a one code and you can use it or call it in different CP files. So the class tree, we will create a tree class in which we will create a pointer root. In constructor we will first assign it null, that we have nothing in the tree. If we are assigning null to root, so mean there is nothing in the tree. Now for insertion a node, so it will be just same code, just we have creating for new node. So the as the node class node is under node underscore t, so the static new node pointer will create a new node for us, and then we will assign it a set data, give it a set data, and we will create two new pointers x and y, just like set left and set right. So we will apply it a condition if root is equal to null. If root is null, so root, the new node should be assigned to the root. Mean if we have nothing in the tree and the root is null, so if we are creating a new node, so the new node should be assigned to the root. But in the first case this will be implemented. Mean if we have we have nothing, the root is null, so the new node will be assigned to the root. But if we are inserting a second node, if we are inserting a second node, so then it will be not true for it. Mean the root will be not null. So for if we are inserting the first node, so the if condition will be applied to it. But if we are inserting a second node, so the else condition will be applied to it. So then the x and y should be assigned to root. The x and y should be assigned if we are inserting the second node, so the x and y should be assigned to the root, while y is not null, so x is equal to y. If data x, then if x get data, y is equal to x get left, else y get right. Mean if we have already assigned a root to it, so then if we are inserting a node to root, so first it will assign it to the left. Either if we have a left node, then it will assign to the right node. Mean if the first node will be assigned to the root, then if we are inserting a second node, so the second node will be assigned to the left of the root, and then if we are assigned the third node, so it will be assigned to the right. And if data x get data, so x set left new node, so it will create a new node at the left, else set right node, so it will be created as a another. It will be done until y is not equal to null. Mean y, it will be running until the y goes to null. So this was a code for inserting new node. As I have told you that for if you want to if we assign nodes, insert nodes in a tree, and then we want to print them in an order, just like one node after another node, as the nodes we have print in like a linked list. So for this we have three orders: the pre-order, in order, and the post order. So in the pre-order, this is a function for a pre-order. So for pre-order we have the root at the start, while then left and then right. So for writing this function void pre-order, so you have to create a r pointer. If r is not equal to null, so if r is not equal to null, so it will be assigned, r will be first assigned to the get data, and then as the get data, r will be assigned the get data mean the root, and then the pre-order, it will assign it will be writing a left and then right. So it will be just like order of root, left and then right. So it will print for us first the root, then the left and then the right. So as the get root is we have used it for the return root, so the get data will be just like it, that it will give us a root. Now for in order, so for in order we have left, root and then right. So for this we have also create a pointer r, so it will give us data until the root, the r is not equal to null, mean it will give us data until it covers all the nodes, mean if it will give print us all the data in this format, in the in order format, mean it will give us first the left, then root and then right until it goes to the last node. So in order, so it will first give us the left, then the get data, the root and then the right. So if we are coming towards the post order, so all the three functions are same, only the order is changed, that you will write the left and right options just like according to the definition of the in order, post order and the pre-order, that for post order you will write the left, right and then the root, then the get data. So now coming towards the main, so the main is we have create a pointer t. For this we have create a new tree, and then we have insert the nodes, and then we call the functions pre-order, the in order and then the post order. So you can just call the functions like this. First we will insert the nodes, and then we will check the output. So here we have the we have insert different nodes in it, and then it is our the post order and the in order and the pre-order. It print the inserted nodes in these orders according to the definitions of these orders. So the task for this lab is that you have to implement the binary search tree using linked list. You have to insert nodes and ask the user that how many nodes he want to insert, and show the nodes. So you have to print the nodes in the post order, pre-order and in order. If you have any problems in this lab, so we can discuss it in the interactive session. And hope that I have fully explained the course to you. There will be no problems in it. Thank you, students.